Hey Algebra 1, and thanks for tuning in. Today we're going to be looking at 6.6 geometric sequences. So this is kind of like when we talked about arithmetic sequences back in chapter 3 or 4, but instead we're talking about geometric this time, so more exponential relationship there. We're going to be looking at 9 things. Let's go and get started. First thing we want to know is what is a geometric sequence, and that basically just means the ratio between each pair of consecutive terms is the same, and the ratio is called a common ratio. Usually whenever that happens, you are multiplying by the same number or dividing by the same number to make sure that your answer is leading to the next one, and that also is maybe showing some exponential growth as well, or decay, determining which one that's being multiplied. So just make sure that you know what a geometric sequence is and the common ratio is. So let's take time now to pause the video here so you can write that down. And then once you're done, click play so we can go on and see number 2. Alright, so the next thing we're going to talk about is how to determine whether the sequence is arithmetic, geometric, or neither, and explain your reasoning. The first one in letter A, we're going to say this one is geometric. And the reason is because you're multiplying by 1/2. Remember, multiplying by 1/2 is the same thing as dividing by 2. So technically those are the same exact thing. So geometric could be multiplication or division by a whole number, but if it's division by a whole number, it's still multiplying by the reciprocal fraction. For letter B, this one would actually be neither, because there's no common sequence. We could maybe say that 2 times 3 is 6, but 6 times 3 is not 11, and 11 times 3 is not 17. And even if you tried to add 2 plus 4 is 6, but 6 plus 5 is 11, and 11 plus 6 is 17. These are not adding by the same number, so we're going to have to say neither for letter B. So these next 3 you're going to try on your own, and you're just going to determine is it arithmetic, geometric, or neither, and then explain why you think that way. Let's go ahead and give you a chance to pause the video here so you can try 2, 3, and 4, and then once you're done, click play to check your work. Alright, so number 2 you should have said is arithmetic, because your common difference is -4. Let's write diff for difference. Okay, so as long as you're adding the same number or subtracting the same number, that's going to represent an arithmetic sequence. For number 3, this one is going to be geometric. And this one is geometric because the common difference, or the common ratio is 1/8. Or some of you might have said divide by 8. And that would be the same thing as multiplying by 1/8. The last one, you should have written neither, because there's no common difference. Okay? So arithmetic, just make sure that your common difference is either addition or subtraction. Geometric is multiplication or division. And then neither would be there's not a same one of those, or there's a mix of the two. The next thing we're going to try to do is find the next 3 terms of a sequence. Both of these are going to be geometric sequences that you see, so you know that you're going to be either multiplying by a whole number or a fraction, and then you're just going to try to figure out that pattern and find the next 3 items. For this one, we should notice that you are multiplying by 2 each time. So 6 times 2, 3 times 2, 6 times 2, 12 times 2, 24 times 2. So the next 3 in that sequence would be 48. And then if you multiplied 48 times 2, you would get 96. And then the last one, if you did 96 times 2, you would get 192. Okay? Letter B is a little bit different. Notice how you go from positives to negatives, but 64 has something in common with getting down to 16. 64 was divided by 4, but since 16 changed to a negative, we're going to say it divides by -4. So 64 divided by -4 is -16. -16 divided by -4 is +4. 4 divided by -4 is -1. -1 divided by -4, you can say 1/4 or you could write 0.25. The next one, if we divide that 1/4 by -4, you can write -1/16 or -0.0625 if you wrote the decimal form. And then -1/16 divided by -4, that would give us 1/64. Or if you wrote the decimal form, that would be 0.015625. Okay, so sometimes you can divide by negative numbers too, and that is fine. You just got to make sure that you're using those multiplication and division properties of your negative numbers. So here are two that you're going to try. Write the next three terms of the geometric sequence. Let's go ahead and pause the video here so you can try 5 and 6, and then once you're done, click play to check your work. Alright, so for this one, we noticed the common ratio for number 5 was multiplying by 3. So your next three numbers in number 5 should be 81, and then 243, and then 729. Okay, for number 6, your common ratio here was, maybe you could say, multiplying by -1/2, or you could divide by -2. Either way, that's going to give you your result for the next three. So -10 divided by -2 is 5, so that'd be your first sequence. And then cut that in half again with a -2, you get -2.5, or -2.5. And then -2.5 divided by -2 again would be positive 1.25, or 1 1/4. Okay? The next thing we're going to talk about is just what the equation looks like for a geometric sequence. So you do want to write this equation down, because we're basically going to be using this formula to plug in some values and write those sequences formulas and then use a calculator to solve. Things you need to know: AN means the nth term of a geometric sequence. So you're going to just label like this in your notes. A1 represents the first term of the sequence. R is the common ratio. And then N represents the nth term. So let's go ahead and take some time now to pause right here so you can write down the equation or the formula and then label it. Then once you're done, I'll show you how it's done, and then you're going to try to on your own. Alright, so it says write an equation for the nth term of the geometric sequence 2, 12, 72, and then 432. So what I'm going to do here is I'm first just going to write down my geometric sequence. AN is equal to A1 times R to the n minus 1, and then plug in my terms. For the nth term, I'll just say AN. A1 would be that first number, and that first number is 2. R is the common ratio, and in this ratio I'm multiplying by 6. So my R is 6, and then I would just keep n minus 1 if I'm trying to find the nth term. Now I want to solve for A10, so I would write A10 is equal to 2 parentheses 6, and then this n now changes to a 10, so 10 minus 1. Okay, which if we simplified, it would be 2 times 6 to the 9th. According though to order of operations, you want to do 6 to the 9th power first and then multiply by 2. Either way, you're going to get a really big number here. It should even out to be 20,155,392. So these do take a little bit of time when you're working them out, but they're very simple once you plug in your values. Okay? So here are the next two, the last two in your notes that you're going to try. Write an equation for the nth term of the geometric sequence, and then find A7, or the 7th term. So let's go ahead and pause here so you can try them, and then once you're done, click play to check your work. Alright, so for number 8, I wrote AN is equal to 1, because that's my first number in the sequence. And then my common ratio is -5. So make sure you provide that -5 there, and then n minus 1. Now I'm ready to do the 7th term, so A7 is equal to 1 times -5, and then 7 minus 1, or 1 times -5 times 6. Now I'm going to do negative 5 to the 6th power first, and then multiply by 1, and that's going to give me a grand total of 15,625. So A7 is equal to that. For number 9, I'm going to set it up the same way. AN is equal to 13, my first number, and then my common ratio is 2, and then N minus 1. Now I'm ready to do A7, so 13 times 2, and then 7 minus 1, which would give me 13 times 2 to the 6th power. Again, you need to do 2 to the 6th power first, which is 64, and then 64 times 13 is 832. Okay, that's going to conclude our notes today on lesson 6.6, geometric sequences. Thanks so much for tuning in, and we'll catch you next time.